So this will be more, just focused on our contributions and what it kind of represents in the world of innovation.
Our contributions to the museum, you mean? Or our contributions to the world?
To the world.
To the world.
Yes. Okay.
Right.
Okay, perfect. Do you have a sense of how many items we contributed, or if you want to just talk about a few that you think are really, kind of the showstoppers?
Are you recording?
Yeah.
I'm John Vozenilek. I'm the Chief Medical Officer for OSF Innovation's Jump Simulation Center. I think one of the main contributions that we provided here at the museum include the three-dimensional hearts. Now, before we got started on the three-dimensional hearts, surgeons would actually look at films through digital screens, and they would look at each slide. Let's say there were 100 slides. Let's say there were 400 slides for a particular patient. Each slide would have information, but the surgeon's mind would have to put all that information together and remember what each slide looked like as they went down through a structure. When we printed our first structures, in this case, tiny babies' hearts, we were able to show the surgeon all the aspects of that three-dimensional model in one fell swoop. And so they suddenly understood all of the dimensions and all of the relationships of all the structures instantly, instead of having to go through this post-processing. So it's a revolutionary way to look at tissue.
Great. I know that you also actually built something here to sort of demonstrate what we use in the labs in terms of artificial, or I should say medical visualization. Can you talk about that a little bit?
What we've discovered over time is that this powerful idea of being able to see better through three-dimensional space really can be taken to a greater scale by using other types of techniques. So we take a clinical image like a CAT scan or an MRI and take that data and produce a three-dimensional image with very high resolution. But that image can occur as a physical model, or it could be in virtual reality. And as you look at the image in virtual reality, sometimes it's actually better and easier because you can expand that model. You can make it as big as this room. And when you do that, you can actually walk through the structures of the heart. So the algorithms to move that forward, the technologies behind it, the technologies to make it faster, better, more accurate, those are all things that JUMP has really invested in.
And you really do see the evolution of medical care at this exhibit. And OSF was a part of it kind of all the way through. There are some other early firsts. Do you see our representation there as showing that we've always sort of been leading?
I think the wonderful thing about the exhibit here is that there were problems to be solved. Whether it's the very first cane that was used to help a blind person cross the street, the problem to be solved there was how could other people recognize that person is blind, cannot see, and needed some additional assistance. Now, we've gone quite a ways in our digital age, but we're still just solving problems. And that's the thing that really inspires me. As we look at each problem in our own age and the technologies that are available to us to solve, we see a myriad of new solutions coming out. And so I do think that as we look at the various displays that are represented here today, we have that same core throughout, which is looking for the problem to solve and then applying the right technologies. What I like to do, though, I'll tell you, is I like to think about what the future technology will be, because maybe there are problems out there that aren't solved yet because we don't even know that there could be a solution.
In some cases, you recognize how long it took for us to really move forward in medical care with some of the problems. It seems as though innovation is speeding up. Inventions seem to be speeding up. Is that your sense?
Yeah. It's my sense that, in general, adoption of solutions, well, it's very well documented that the adoption of a medical solution at times took decades. For example, the discovery that vitamin C helped prevent scurvy, well, it was more than 80 years before they started putting fruit and vegetables onto ships going across seas to prevent scurvy. Okay, that is not the digital age. In the digital age, everyone has information all the time, immediately available. And part of that information are all the different things that are like how-tos. And what we're seeing is the creative people that are out there able to bring in technology A, pair it to technology B, all researchable, all immediately available, gives great expansion of discovery. And so what we're seeing here is just a rapid expansion of new ideas and solutions. It gets faster every day.
I know that visitors are going to be able to vote on the top medical invention. Would you have one if you were casting your ballot, or maybe your top 3? I know, I threw that one at you.
I'm really a great fan of medical invention. And you have to look at some of the things that are just totally transformative. In our history, when we first discovered that germs actually exist, that was a huge breakthrough. It totally changed the way we think about disease. In the future state, I think we're going to see a lot more reliance on the body's innate systems to combat disease and cancer. And I think it's a partnership, really, that happens between the body and the human condition and what technology can provide. So I'm always very enthusiastic for things that are like regenerative medicine, where the body's own cells actually create new structure, healthy structure, or where the immune system is brought along to combat cancer inside a patient's body. I think that's where we're headed. And I think the digital technology that's available to understand the human genome, the structures of the cells, and all of the makeup of individual cells and how they're composed and how they relate to each other is really where it's at for us. Now, I'm really proud to be a very small sliver of the whole idea of regenerative medicine. You know, the idea that three-dimensional scaffolding can be printed and stem cells, adult stem cells, placed on that scaffolding to create new tissue. You know, I really hope that in the future, some of the technologies we made to make the image capture and extract that image capture and make it faster and more reliable actually have a home for regenerative medicine in the future.
For the items at the exhibit that are on display, either from us or anybody else, what do you think is the most important innovation in the history that's represented there?
I think the key tie-in for us here at JUMP is this tie-in to three-dimensional printing and how three-dimensional printing has impacted not just visualization but patient care. So when I look at the displays here, I'm very attracted to this idea that 3D vision is so terribly important. I think it inspires people, I think it informs people, and I think it informs science.
Perfect. I can't think of anything else unless there's anything.
Cool if you are.
Okay.